Remember, solids are less compressible. We cannot compress the solid substances. Total number of nearest neighboring particles. See the sentence. Okay, it is very important. We all know that solids are of two types. One is amorphous and the one is crystalline. Volume occupied by the space is nothing but 4/3 pi r cube. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to do a revision class for the second PUC Chemistry. In that, we'll start with the Unit 1, the solid state. So, before going to understand which are the important questions will comes under this unit, let us see the introductory part of this unit. So, already in your first PUC, you have learned the states of matter. In that, you have learned about a liquid state as well as a gaseous state in detail. When you come to the second PUC, you are going to understand more about the solid state, how the particles are arranged, and what are all the importance of solid states of the matter you are going to understand with this unit. Okay, and we all know that this unit will come under the physical chemistry, the first unit also. Okay, let us see with the introductory part of this unit. The solids are the chemical substances which are characterized by a definite shape, volume and rigidity and have a high density also and low compressibility, and the constants of the particles are closely packed and held together by strong interparticle forces. We all know that when we see the solid objects, or the solid substances, it is having a strong intermolecular force of attraction between the particle, and they have a definite shape, definite volume, and also it possesses the definite density also. And remember, solids are less compressible. We cannot compress the solid substances. So more about this unit, we are going to understand in the unit name called as solid state. Okay, let us see the weightage of this unit. So from this unit, we can expect the 8 marks. In that, we can expect the one question in the part 1, that is a 1 mark question, and we can also expect the 2 mark question in the part B, that is a question number 16, and also in the part D, that is from the physical chemistry, you can expect one 5 mark question. In that, the question number 36 will definitely come from this unit. Okay, and remember, in a 1 mark question, they can ask any types of the solid substances that you are going to learn in this unit, and also in the 2 mark question, you can expect any differences or calculate the number of particles per unit cell in the FCC, BCC or in the simple cube, or you can expect any question in the 2 marks from the magnetic behavior of the solid. Okay, and coming into the 5 mark question, definitely you have a packing efficiency numerical for the 3 marks, and also you can expect one numerical for 2 marks based upon the density. This is just an outlook about the unit called as solid state. Hope you all understood with the how the question can be raised from this unit. Let us see what we are going to discuss in this unit. We are going to discuss with the possible 1 mark question from this unit, 2 mark as well as with the 3 mark questions. Let us see with the 1 mark question. So, always from this unit, we can expect the question from the S center, or we can expect the question from the coordination number, or we can expect the types of cells in the solid state, and also we can expect the question, 1 mark question from the magnetic behavior. Okay, let's see with the few question now. Define coordination number of a particle in solid. So, hope you are familiar with this question. It is nothing but total number of nearest neighboring atoms or a particle which is present around the atom. It is a total number of nearest neighboring particle to the given particle, which is said to be what? Coordination number. Next is F center. So we all know that F centers are nothing but anionic sites which are occupied by unpaired electrons. Okay. So in your answers, the evaluator will see the anionic sites which are occupied by unpaired electrons. Okay. Even in the coordination number also, they see that coordination numbers are nothing but total number of nearest neighboring particle. They see the sentence. Okay. It is very, very important. Keep a point in your mind when you are writing the answers precisely in the course subjects, they see the answers directly from the NCERT textbook. So, it is very important to refer the NCERT textbook as well as with your notes also. Okay. Next, name the types of non-stoichiometric defects which is observed when white zinc oxide turns into yellow or heating. So, when you take the zinc oxide, it turns into yellow. What is the defects that you can call for this types of defects that you found in the solid state? So, that defects is nothing but metal excess defects. So, based upon the defects also, you can expect any of the one question. Next, which defects are also called as dislocation defect? It is nothing but Frankel defect. Okay. Next, what is doping? We all know that doping is nothing but process of increasing the conductivity of the solid on a intrinsic semiconductor by adding a suitable impurities. Okay. Whenever you take any semiconductor, if you want to improve its conductivity, we will add some of the impurities for that. This process of adding the impurities to the semiconductor, which type of semiconductor it is? Intrinsic semiconductor. Such type of process we call it as what? Doping. Next we have, what is the type of semiconductor which is obtained when silicon is doped with boron impurity? Remember, silicon is doped with boron impurities. Such type of semiconductors are nothing but P type of semiconductors. Okay. Next, what is the color which is imparted to the NaCl crystal due to the presence of excess of sodium? So, the color of the sodium crystal is yellow due to the presence of excess of sodium chloride. Name the crystal defects which lowers the density of the ionic crystal. We all know that Schottky defects is a one defect, which always lowers the density, whereas the Frankel defect, it does not affect on the density. Next, when a solid is cut with the sharp edge tool, they cut with the two pieces and newly generated surfaces are plain and smooth. Identify the types of solid. So, such types of solids are nothing but crystalline solids. We all know that solids are of two types. One is amorphous and the one is crystalline. Which type of forces of attractions are present between the molecules in polar molecular solid? And we know that in case of solids, in case of polar solids, the interaction is dipole-dipole interactions. Next, we'll move on to the 2-mark question, that is, write the differences between crystalline and amorphous solids. Just now I said, so solids are broadly classified into two types, one is crystalline and the one is amorphous. So, how to write a precise answer when they ask the differences, look at with these answers, it is very precise. If they ask you to write for 2 marks, any 2 points which has to be precise, you can choose any 2 points and you can write it for your exam. So, in the crystalline solids, we know that it is also called as true solid, whereas amorphous solid, we know that it is called as pseudo solids. Okay. Next, it has a definite geometry and it do not have a, usually we say it is having irregular geometry or a irregular shape. Okay. And it has a long range of order it has a short range of order and it has a sharp melting point, and usually the amorphous solids are softened over the range of temperature. And we all know that the crystalline solids are anisotropic in nature, whereas the amorphous solids are isotrophic in nature. Okay. Next, it has a definite heat of fusion, whereas the amorphous solid do not have a definite heat of fusion, and it can be cleaved along with the definite plane. It cannot be cleaved by a definite plane. So, any two proper differences you can write it for the exam to get 2 marks. Okay. Next differences is differences between the Frankel and Schottky defects. So, this is also most short question for your exam. Okay. Remember, in these types of defects, you have to name what is a Frankel defects and what is a Schottky defects. In addition to this, what is the effective density, that is the main thing that you have to write it for the differences for the Schottky and the Frankel. So, we know that Frankel defects are nothing but the ion which occupies at interstitial position than that of the actual lattice position. Okay. Here, we know that in the Schottky defects, both cations and anions are missing from the lattice position in the crystal, which is said to be Schottky defects. So, here the density remains same. So, the Frankel defects are never affected by the density, whereas the Schottky defects, it is get affected by the density and always decreases the density. Okay. It is found in ionic compounds which having a low coordination number. It is also found in the ionic solids which has a higher coordination number. Okay. Then it has a larger differences in the size of the ions in the ionic solid, and examples are zinc sulfide, silver chloride and silver bromide. Next, we have the ion size, because it is an example for the ionic solid. The size of the ions are usually smaller in case of the Schottky defects. Usually the sizes are small of cations than the anions. Okay. And examples are sodium chloride, potassium chloride, cesium chloride or silver bromide. You can read any of the two examples for this kind of differences. Any two differences is enough again for your exam. Next, we have most important question from the magnetic behavior, that is, what is ferromagnetic substances? Give an example. Sometimes, they can ask you to write with the domain structures of this magnetic behavior of the substances. So, all the 5 magnetic behavior like diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic, antiferromagnetic, all the 5 definition along with the suitable example and how these domains are arranged. Okay, everything you must know for your examination point of view. Okay. So, the substances which are strongly attracted by the magnetic field are called as ferromagnetic substances, and the phenomena which is known as what? Ferromagnetism. Example, iron, cobalt and nickel. These are the solid substances which are shows a greater attraction towards a magnetic field, hence they are known as what? Ferromagnetic substances. Okay. Next, what is ferrimagnetic substances? Give an example. The substances, even though which have an unpaired electron, like a domain like structure which I have shown here, the ferromagnetic substances, but they are weakly attracted by the magnetic field, they are known as what? Ferrimagnetic substances. So, the differences between the ferri and ferro, you must understand. Ferromagnetic substances are strongly attracted by the magnetic field because of the unpaired electron. But in case of ferrimagnetic substances, even though you have unpaired electrons like a domain structure as you can see in case of ferromagnetic substances, they are weakly attracted by the magnetic field. Why they are weakly attracted by the magnetic field? Because these domains, they are present in an opposite spin. You can see that they are present in an opposite spin, and few of them can present with only one alignment. Okay, if they are present with the opposite alignment, they get cancelled out. Because of the alignments are opposite to one another, they get cancelled out. They are weakly attracted by the magnetic field. Example, Fe3O4, that is magnetite, and ferrites like MgFe2O4 and ZnFe2O4 are the example for the ferrimagnetic substances. Okay, hope you all understood why the magnetic behavior is not observed here, because their domains are opposite to one another. If the domains are opposite to one another, they get cancelled out. That is why they are weakly attracted. Next, we'll solve the numerical. It can also be asked for your examination. That is, an element which are having the atomic mass 60 has a face-centered cubic unit cell. The edge length of the unit cell is 400 picometer. Find the density. We all know that from this unit, definitely based upon the density, the numerical can also be asked for the 2 mark. So that is why I have set the 2 questions to solve based upon the density. So we'll solve with the density. First of all, write down the formula for calculating the density, that is D is equal to Z into M divided by A cube into Na. So we know that M they have given, that is atomic mass they have given, that is 60, and they have said that it is a face-centered cubic unit cell. So Z is nothing but a 4, and the edge length of the unit cell also is given, that is the A they have given. What is the A here? 400 picometer. When you are converting this picometer into nanometer, or you are converting this picometer into meter, you will write it as 400 into 10 to the power of 10 meter. Since it is A cube, I will multiply as A cube. Okay. Next, find the density, and we know that what is the Na value, that is Avogadro number value, that is 6.023 into 10 to the power of 23. Okay. Now just substitute for the above equation. What you will get? What is a Z here? 4 into 60 divided by, what is A cube now? 400 into 10 to the power of minus 10 whole cube into 6.023 into 10 to the power of 23. Okay. Just multiply these two. You will get 240 divided by 400 whole cube you have to do. Just do the whole cube for the 400, then multiply with the 6.023. Then the 10 to the power of 30 and 10 to the power of 23 will be minus. So, we will do the subtraction, and finally, we will write the answer for this. Okay. It is 1200 into 10 to the power of 30 into 6.023 into 10 to the power of 23. Finally, I will write the answers as just by multiplying the A cube value with the Na value. Then I will subtract 10 to the power of 30 with the 10 to the power of 23. 6.226 gram per centimeter cube. 6.226 gram centimeter cube. This is the answer for your density. So, because the meters will go upside, it should be -3 only. Okay. This is how we know the density of the given cell can be easily calculated by looking at with the given data. So, we will solve one more numerical so that you can easily understand. Silver forms a CCP lattice, and X-ray studies of crystal shows the edge length of the unit cell is 408.6 picometer. Calculated density of the silver, and atomic mass they have given, that is 107.94. So, since they have given the M, what is M here? So, 107.94. So, they have given A cube value also, that is A value 408.6. I can write this also as what? 408.6 into 10 to the power of minus 10 whole cube. Okay. Then, silver forms a CCP they have given. CCP in the sense, it is nothing but face-centered cubic unit cell only. We know that for the face-centered cubic unit cell, so number of particle is 4. So, I will write Z as directly as 4, and we know that what is the value of Na, that is 6.023 into 10 to the power of 23. So, now we will substitute for the equation, that is D is equal to Z into M divided by A cube into Na, and we know that Z is 4 and M value they have given, that is 107.94 divided by AK value is 108.6 into 10 to the power of 10 whole cube into 6.023 into 10 to the power of 23. Okay. So if you do this multiplication and multiply it with the 408 3 times with the 6.023, finally you will get the answer as so this is the final answer you will get it while solving with this numerical, that is 10.5528 into 10 to the power of 3 kg per meter cube. Okay. Next we'll go with the other part of this unit. They are also going to ask definitely with the number of particles to find it out with the simple cube or with the CCP or with the BCC. Okay. We'll see with the simple cube first, that is nothing but a primitive unit cell only. Calculation of number of atom per unit cell in primitive cubic unit cell, which is also known as what? Simple cube. Okay. So we know that in a simple cube, there are 8 corners will be there. Each 8 corner will contribute 1 atoms. So you can see that this is a simple cube. There are 8 corners will be there, 4 up and 4 below. Each corner will contribute 1 particle. So since each corner are shared equally by 8 unit cell by the each 8 corner particle, so we write the number of particle in a simple cube as 8 into 1 by 8. So there are only 1 atoms will be there in the simple cube. So if you have this basic, you can easily solve the numerical based upon the density. If you don't know how many particles will be there in a simple cube or BCC or in FCC, it's not very easy to go with the numerical based upon the density. Next, calculation of number of particle per unit cell in body centered cubic unit cell. So remember, when you are writing the calculation part, keep that in a point that in all these cubes, there are 8 corner particles will be there. Each 8 corner particle will contribute 1 particle. In addition to this, say that whether it is a simple cube or BCC or FCC, if it is BCC, in addition to the 8 corner particle, we have particles at the center. Okay, that will also contribute 1 of its particle. Okay, each atom at the corner at the position contribute 1 by 8 of the unit cell. The contribution of the 8 corner atom in each cell is 1 atom, so that the atom of the center of the unit cell is not shared by any other unit. You can see that the atom which is there at the center, it's not shared with any other cells. Correct? No? So that is why the contribution of total number of cells in BCC can be calculated as what? So 8 into 1 by 8 plus 1. 8 will get cancelled. 1 plus 1, it is how much? It is 2. Okay. Next, we will see with the frame-centered cubic unit cell. Here also you can see that there are 8 corner particles will be there. In addition to the 8 corner particle, we know that 8 corner particle will contribute. So 1 by 8. So each will get cancels and you will get a 1. In addition to the 8 corner particle, we have particles at each faces. You can see that there are 6 faces will be there. So each 6 faces will contribute 1 particle. Since there are 2 faces will be there, I have written as 2. So 2 3s are, so you will get 3. So how many particles we have? 4 particles in the FCC. Okay, same calculation you have to do as I have shown here. Next, we'll move on with the most important part of this unit, that is packing efficiency. Remember, when they ask you to write the packing efficiency of the simple cube or a BCC and FCC, keep that in a point, first you have to write this cubic cell and show that which particle you are going to explain. Suppose if it is a simple cube, I am going to show this 2 corner particle. Okay, it has to touch one another. Okay, then derive the formula up to the values of edge length, then write the formula for the packing efficiency, then substitute the values, then write the percentage. Okay. So here I have shown that edge length of the entire cubic unit cell is A and we know that the radius of the particle is nothing but r. You can see that there are two particles I have considered. So I have considered A is nothing but 2r. Okay. Then in a simple cube, we know that there are only one atoms will be there. Then volume of the cube, okay, volume occupied by the space is nothing but 4 by 3 pi r cube. We know that the volume of the cubic unit cell is nothing but a cube, and we know that what is the value of a, that is 2r into whole cube, which is nothing but 8r cube. Finally, write the packing efficiency formula, that is nothing but volume of the sphere divided by total number of total volume of the cubic unit cell into 100. Since we are dealing with a simple cube, I will write one sphere so that it is 4 by 3 pi r cube divided by 8 pi r cube into 100. This r cube will be get cancelled out, and if you do this simple calculation, you will get pi r divided by 6 into 100, which is nothing but 52.4%. I will go with one more example. Calculations of packing efficiency in face-centered cubic unit cells. Whenever I say it is a face-centered cubic unit cell, again write down the cubic unit cells first, then write down the two particles at the corners and show that one particle which is there at this face. Because it is a face-centered cubic unit cell, write down the diagonal to show that they are diagonally related to one another, and show that how this edge length are also related to r. Okay. So we know that A is edge length, R is the radius, and as I said, I have drawn the diagonal from AC, which is equal to B. Okay. So in the triangle ABC, you can see that I have taken this triangle ABC. So AC square is equal to BC square plus AB square. We know that AC square is nothing but B, as I have written. Then AC and BC, we know that they are nothing but edge length. So B square is equal to 2A square and B is equal to A into root 2. Now we know that R is the radius of the sphere. So B is equal to 4R, I can write, and B is equal to 4R is equal to A into root 2. Why it has become 4R? You can see that this is 1R and this is one more R, 2, 3, then 4. So B will be equal to how much? 4R. Okay. Then substitute the values here. A is equal to 2R into root 2. Now the volume of the cube will become A cube. So if you multiply this whole values into cube, you will get 2R whole root 2 into whole cube. And we know the volume of the sphere, it is nothing but 4 by 3 pi r cube. Then substitute the values with the number of particles which is there in the FCC, that is 4. Then finally put the formula for the packing efficiency. Then substitute the volume of the 4 spheres divided by total volume of the unit cell. If you do the simple calculation, you will get the 74%. Okay. Next, calculations of packing efficiency in body-centered cubic unit cell. Since it is a body-centered cubic unit cell, you have to show the particles at this corners and one more particles at the middle, that is a C. Okay. Then relate the values of A with the edge length along with the R. So we know that A is the edge length, R is the radius. So let FD will be the face diagonal, as I said. And also, you know, from the triangle EFD, as I have drawn one more diagonal, okay, to show that how the B and how the A are related to one another. Finally, I get the values for the C, that is C is equal to 4R. Then we are writing the packing efficiency formula, that is the volume of the 2 sphere. Why it is 2 sphere? It is nothing but simple cubic unit cell which is containing a body center. So we know that in the body center there are only 2 particles will be there. So volume of the 2 spheres. So volume of the 1 sphere I know, that is 4 by 3 pi r cube into 2, and this is the value of total volume of the unit cell into 100. If you do that simple calculation, you can write this percentage as 68. So if you don't know that calculation and all, just substitute the values and write the percentage, and this is how you know the percentage or a packing efficiency of simple cube, BCC and FCC can be calculated with showing the cubic cell, specifically showing the particle, relating A and R, then writing the packing efficiency formula, writing the volume of the sphere, writing the total volume of the cell, then writing final percentage to show that this is the packing efficiency. Hope you all understood with this session. I'll come back with the one more unit, that is our unit 2 solution. Till that, take care, be safe. Thank you.